Elon Musk, known for his work in revolutionary projects like electric cars and space exploration, recently made a surprising announcement about the historic Voyager mission. As someone who openly loves science, Musk's latest news has shocked many scientists and space experts around the world. He spoke about the future of the two Voyager spacecraft, which have been traveling through deep space for decades, and how much longer they might continue their amazing journey. In a special video, Musk revealed an incredible space discovery and invited everyone to join in what he called a unique adventure beyond our solar system. Musk feels a personal connection to the Voyager probes. When he was just 6 years old, NASA launched Voyager 1 and Voyager 2, two spacecraft that have now become icons in space history. Musk's rockets are launched from Cape Canaveral in Florida, the very same place where the Voyager spacecraft first took off into space. It is astonishing to think that more than 50 years later, these probes are still working and sending information back to Earth. At the time they were launched, no one expected the mission to last so long. The original plan was for the probes to operate for only a few years, but they have far surpassed those expectations. Over the decades, the Voyagers have continuously sent new and valuable data about planets, moons, and the vast universe beyond. Many people do not know that the Voyager mission was only possible because of a rare alignment of 4 giant planets: Jupiter, Saturn, Uranus, and Neptune. This special arrangement of planets had not happened since the early 1800s, during the time of Thomas Jefferson. The alignment allowed the spacecraft to receive a series of gravitational boosts, like invisible strings pulling them forward as they passed by each planet. This clever idea was created by a NASA engineer named Gary Flandreau, who worked at the Jet Propulsion Laboratory. His plan shortened the travel time to Neptune from what would have been 30 years down to just 12 years. This planetary alignment only happens once every 176 years, so NASA had to act quickly to take advantage of this rare chance. Instead of sending just one spacecraft, they decided to build 2 identical probes to explore the outer planets. Each Voyager probe was about the size of an old Volkswagen Beetle car and had a computer with only 69 kilobytes of memory, which is tiny compared to modern devices. Even today, a simple car key remote has more memory than these spacecraft had. Despite their limited technology, the Voyagers were equipped with 8-track tape recorders to save the data they collected from their scientific instruments. They sent this information back to Earth using a transmitter with about the same power as a light bulb inside a refrigerator. To make sure the signals could travel such huge distances, each probe was fitted with a large 12-foot wide dish antenna to send and receive messages across space. Since their launch in 1977, the Voyager spacecraft have made many important discoveries. Voyager 1 holds the record as the farthest human-made object from Earth. It is now traveling through interstellar space, billions of kilometers away from our planet. Being so far from the Sun means that solar power cannot be used to keep the spacecraft working. Instead, both Voyagers rely on special power sources called radioisotope thermoelectric generators, or RTGs. These devices use plutonium-238, a radioactive material that produces heat as it decays. The heat is then changed into electrical energy to power the instruments and transmitters on board. When first launched, each Voyager produced about 470 watts of power at 30 volts DC, but this power has slowly decreased over time. Despite this, RTGs remain one of the few reliable ways to keep a spacecraft powered for decades while traveling through deep space. After traveling for 546 days, Voyager 1 finally reached Jupiter in March 1979. Voyager 2, which had launched a few weeks earlier, arrived at Jupiter in July of the same year. These probes were designed to act as very stable platforms for their cameras. Their cameras used special filters to take full-color pictures of the planets and their moons. Unlike the fast rotation of planets, Voyager spacecraft moved very slowly, about 15 times slower than the hands of a clock, to ensure the images were clear and sharp without any blurring. This careful design helped the probes capture amazing details from millions of kilometers away. Voyager 1 started sending pictures of Jupiter even months before it got close to the planet. The quality of these images was outstanding. One surprising discovery was Jupiter's moon Io, which had bright colors and active volcanoes. Before Voyager, scientists thought moons would be like Earth's moon, quiet and lifeless, but Voyager showed a variety of landscapes on moons around Jupiter and Saturn that were completely unexpected. Voyager's instruments also detected unusual particles called oxygen and sulfur ions far away from Jupiter. These particles appeared in levels much higher than ever seen before, which puzzled scientists. At first they thought it might be an error, but later they realized that something extraordinary was happening around Jupiter. The Voyager cameras revealed that Io is the most volcanically active place in our solar system. This moon, slightly bigger than Earth's moon, showed 10 times more volcanic activity than Earth. Its volcanoes shoot plumes of material up to 30 times higher than Mount Everest, covering an area as large as France. The bright colors and strange particles detected by Voyager were caused by materials thrown into space by these intense volcanoes. Voyager's cameras took over 33,000 pictures of Jupiter and its moons, showing many new details. For example, scientists were surprised to learn that Jupiter has rings, something they had not expected. Another moon, Europa, was seen to have a thick, cracked, icy crust over 60 miles deep, raising new questions about its geology and possible oceans beneath the surface. As the Voyager probes continued their journeys, Voyager 1 flew past Saturn, passing through its famous rings and getting close to Titan, Saturn's largest moon. Meanwhile, Voyager 2 traveled farther to Uranus and Neptune, where it made even more important discoveries. Voyager 2 found 10 new moons around Uranus and confirmed that Neptune, like Saturn, also had rings. These findings increased our understanding of the planets in our solar system. In 1989, Voyager 2 came within about 2,180 miles of Neptune and recorded the fastest winds ever measured in the solar system, reaching speeds of up to 1,000 miles per hour. It also showed that Triton, Neptune's largest moon, is one of the coldest places in the solar system, with temperatures dropping as low as 235 degrees Celsius. Despite these freezing conditions, Triton has ice volcanoes that spew nitrogen gas and particles up to 5 miles into the air, adding another surprising discovery to the Voyager mission. One of the most famous moments of the Voyager mission happened in 1990. After completing its photos of Neptune and its moons, NASA was ready to turn off Voyager 1's cameras. However, the well-known astronomer Carl Sagan asked NASA to let Voyager 1 take one last series of pictures. NASA agreed, and on Valentine's Day 1990, the spacecraft turned its camera back toward Earth and took 60 images. Among these was the iconic pale blue dot photo, showing Earth as just a tiny speck from 3.8 billion miles away. This image remains one of the most distant photos ever taken of our home planet. Today, both Voyager spacecraft are still in contact with NASA, even though they move farther away from Earth by about 3 to 4 light seconds each day. NASA uses the Deep Space Network, which includes 3 tracking stations located around the world, to send commands and receive data from the probes. Both spacecraft have crossed the heliopause, the boundary where the Sun's influence ends and interstellar space begins. Voyager 1 crossed this boundary in August 2012, and Voyager 2 followed more than 6 years later. Even after all these years, the Voyagers continue to surprise their controllers. Recently, Voyager 1 sent back signals that did not match the expected patterns for its altitude and orientation control systems. Scientists are now trying to understand if this data is real or just random noise. Despite being over 45 years old and using outdated technology, Voyager 1 remains one of NASA's most valuable spacecraft, showing remarkable performance throughout its mission and continuing to explore the mysteries of deep space.